introduction to the polynomial function. So what is a polynomial? Poly means many, nomials means nomial. So polynomial means a nomial with many nomials. So polynomial functions have graphs that are smooth and curvy, that is there are no pointy bits. There is nothing like this, no pointy bits. They are continuous, there is no breaks or gaps or holes. They go on forever, they have arrows on the ends. Okay. So what are the common polynomial functions? This is a constant function. So you can see that it has arrow on the head, it goes on forever. This is a linear function. Linear function, linear means 1 with the degree 1. This is a linear function which is a graph with the arrows on the head. Quadratic functions with the degree 2. Cubic functions with the degree 3. Quartic functions with the degree 4. And quintic functions with the degree 5. So let's work on the degree of polynomial. Degree of a polynomial function is equal to the highest power exponent on x in the equation. For example, every quadratic function is degree 2. We know that quadratic function is a function of degree 2. What is the degree? The highest power in any polynomial is known as degree. And quadratic function has highest power 2. So it's a function of degree 2. The degree of the polynomial tells you the maximum number of x-intercepts the polynomial could have. Degree of the polynomial means the function has maximum x-intercepts, or the graph is intersecting the x-axis at the maximum points. Therefore, any polynomial of degree n has n roots, but these roots may not always be real. So if we have a polynomial equation of y is equal to k, so we have x to the power 0 over here. So this is the type of the function is constant. The degree of this function is 0 and x-intercepts in this would be 0. Now here the power of x is 1. So type of the function would be linear. Degree of the function would be 1 and the maximum number of x-intercepts would be 1. Okay, the degree of the function is 2. It is quadratic and the maximum number of x-intercepts would be 2. Degree of the function is 3. It is called cubic and maximum number of x-intercepts would be 3. Degree of the function is 4. It is called quintic. Quartic. Degree is 4 and x-intercepts are 4. And the next would be quintic or heptic or octic and furthermore. So you can see that in the constant, the x, how many, this is the graph of a constant function. So is it intersecting with the x-axis? No. It is, there are no points at which it intersects with the x-axis. So the maximum number of x-intercepts are 0. It is a linear function. So linear function is intersecting with the x-axis at only one point. So quadratic function is intersecting with the x-axis at 2 points. Quintic function, so it's 2. So quintic is intersecting with the x-axis as 1, 2, 3 points. So it has x-intercepts 3. Quartic function is intersecting 1, 2, 3, 4 points. So it has x-intercepts 4. So what are the x-intercepts? The number of points at which the function intersect with the x-axis. It is called the degree of the function or the x-intercepts or the roots of the function. Determine which graphs below represents polynomials. If the graph is a polynomial, determine the possible degree of the function. If not a polynomial, give a reason why. First of all, we would like to know that if this is a polynomial or not. Yes, because polynomials never end. So it is never going to end from here, never going to end from here. So yes, it is a polynomial. Then what will be the degree? 1, 2, 3, 4, 5, 6. Degree is 6. So it is not going to end from here, but it is ending from here. So it's not a polynomial. This is not ending from both sides. So yes, this is a polynomial. And the degree is 1, it means it's linear polynomial. Okay, it has a pointy bit. If we have pointy bit, it's not a polynomial. Okay, it's never ending. Yes, it's a polynomial. And 1, 2, 3, 4, 5 of degree 5. And this is ending over here and over here, so it's not a polynomial. Okay, the equation of a polynomial function can be a monomial. If it has one term, it is called monomial. Mono means one. If it has two terms, bi means two, it's called binomial. If it has three terms, tri means three, it is called trinomial. Has exponents or powers of x that are whole numbers. Exponents or the powers on the x will always be the whole numbers. It cannot be fractions or the negative numbers. For example, we cannot have x to the power -2, or we cannot have square root of x in the polynomial. Polynomial always have whole numbers as the power of x. It does not have fractions or the negative numbers. It has coefficients that are the real numbers, integers, fractions, or irrational numbers. So determine which equation below represents polynomials and which do not. If it's polynomials, identify what type of polynomial function is it, monomial or binomial. If it is not, state why. So we have f of x. First of all, we need to determine if the equation below represents a polynomial or not. So for the polynomial, all the powers of x should be the whole numbers. This is not a whole number, so it's not a polynomial. So these all the powers of x are polynomials, and x into x would be x square. So it's a polynomial with degree 2, quadratic or binomial. Okay, it is with 1/2, so not a polynomial. It has the fractions, so not the polynomial. So it is a polynomial with degree 3, which means cubic. Consider the graph f of x below. State the degree of the polynomial. Degree of the polynomial is 1, 2, 3. Domain -infinity to +infinity. Range is -infinity to +infinity. X-intercepts are 3. Sorry, what are the x-intercepts? -1, 3 and 5. -1, 3 and 5. So it can be written as f of x can be written as x plus 1, x minus 3, x minus 5. And here the coefficient of x cube is +1, so it would be a would be 1. 1 is very important because it means the function is positive. It means increasing trend. If there is a positive number here, it means it is in the increasing way. So you can see here it is negative number. Negative means decreasing. So it is decreasing here. State the degree of g of x. So 1, 2, 3. X-intercepts -2, 1, 3. Here I will put -1 because here it is negative, which means decreasing trend. Describe how the graph of a cubic function with a positive leading coefficient is different from a cubic function with a negative leading coefficient. So leading cubic with positive leading coefficient means a. A represents leading coefficient, means like this, increasing trend. And negative leading coefficient, which means like this, decreasing trend. Consider the graph of h of x. State the degree of the polynomial 1, 2, 3, 4. Domain, range, x-intercepts, What do you think would happen if a is equal to -1? So here a is +1, so a is -1 reflect over x-axis. And behavior of polynomial functions. The way a function f of x behaves for very large values of x or very small values of x is called end behavior. To determine the end behavior of a polynomial function, we looked at the far left x values and far right x values. So if r is equal to f of x, x gets more negative, f of x get more negative. Here x is getting more negative on this side, f of x is getting more negative on this side. X is getting more positive on this side, f of x is getting more positive on this side. So state the possible degree which polynomial and then describe its end behavior. So the degree would be 1, 2. The possible degree of each polynomial and then describe one, two. Okay, so as x is going towards the this is the x going towards positive side, x approaches to positive infinity, f of x is also going towards positive infinity. As x is approaching to the negative infinity, f of x is again approaches towards positive infinity. So it's 1, 2. X approaches towards positive infinity, f of x approaches towards negative infinity. X approaches to negative infinity, f of x approaches to positive infinity. X approaches to positive infinity, g of x approaches to negative infinity over here. X approaches to negative infinity, g of x approaches to negative infinity. X approaches to positive infinity, k of x approaches to positive infinity. X approaches to negative infinity, k of x approaches to, here x is going towards the negative infinity, so kx is going towards negative infinity. Describe the end behavior of the function f of x is equal to 3x to the 7 plus 5x 4 minus 7. So the degree of this function is 7, which is the highest power. Write an equation in intercept form for each of the following polynomials. -3, 0, 4, x plus 3, x plus 0, x minus 0, x minus 4, which is equal to p of x. minus 5 minus 1 2 x plus 5 x plus 1 x minus 2 minus 2 minus 1 1 2 x plus 2 x plus 1 x minus 1. Here it would be x plus 1 x x minus 3 x minus 5. Based on your observations from question number 1, select the correct words to make each statement true. If p of x is approaching towards the positive infinity and x is approaching towards the negative infinity, p of x is approaching towards the positive infinity and x towards the positive infinity, then the degree of the polynomial is p of x towards polynomial towards positive infinity and x towards the positive infinity, x towards negative infinity and p of x towards the positive infinity. This one, p of x towards positive infinity, x towards positive infinity, x negative and p of x positive. So we are talking about the option C. The degree of the polynomial is 1 2 3 4, that is even, and the leading coefficient is positive. If p of x is negative infinity and x is negative infinity, p of x is negative infinity, x is positive infinity, and degree of the polynomial, talking about the option D, degree of the polynomial is again even and leading coefficient is negative. Now p of x is positive infinity and x is negative infinity. This one, p of x is negative infinity and x is positive. Option B. The degree of the polynomial here is 3, that is odd, and the leading coefficient is negative. The last one is p of x is negative infinity when x is negative and positive when x is positive. The degree of the polynomial is 3, that is odd, and the leading coefficient is positive. So what we get, we get to know that if it is behaving positive, negative, positive, positive, it's even and positive, even in negative, odd in negative, odd in positive. Consider the graph of p of x. State the degree of the p of x 1 2 3 4 5. Sign of the leading coefficient, so increasing trend means positive, which could be the graph of the 4th degree polynomial with leading coefficient negative 3. So 4th degree polynomial, it's 1 2 3 1 2 3 1 2 3 4. So 4th degree polynomial can be it is 3 degree, it is 3 degree, so it is 4th degree and it is 4th degree, and negative 3 means opens down. So this is the answer. Which of the following polynomials can be written in the standard form? Circle all answers that apply. Okay. Write an equation for a 5th degree polynomial with a leading coefficient 7 and a constant term -1. Write each polynomial function in statement form and determine the degree, value of the leading coefficient and value of the constant term. Leading coefficient -1, degree is 4, and the constant is 0. Circle all the equations below it represents polynomial functions. So we know polynomial functions do not square index. This is not because -4. This is not a polynomial function because no polynomial should be there in the denominator, because no exponent should be there in the no 1/2 in the denominator. So this is again a polynomial function. Let me write the reasons here. No negative exponents allowed, no polynomials in denominator. One by two fractional polynomials are not allowed. Variable exponents are not allowed. Select the correct equation for the polynomial degree, polynomial graph here. First of all, it is the polynomial for degree 1, 2, 3. So it's 0, 4 to -2.5. So it should be x minus 0, x minus 4, x plus 2.5. So x plus 4 are cancelled. We have two options, x negative 4 and x with 2x minus 5 or 2x plus 5. So it would be x plus 2.5, so it's 2x plus 5. So option C is the correct answer. Leading coefficient of 3. Okay, so leading coefficient here is degree 3. Degree here is, leading coefficient is 3 here, degree of the polynomial is 3, constant term here is plus 36, y-intercepted 0, 1. Okay, leading coefficients. This 3 is the leading coefficient. Here 5. So leading coefficient of 3 is A. Degree of 5 is B. Constant 36 is minus 36, this one. Y-intercept of 0, 1 means constant should be 1. Which of the following represents a trinomial with a leading coefficient of 3 and constant term of -5? Represents a trinomial. Tri means 3 nomials, 1 2 3 1 2 3 1 2. This is cancelled, 1 2 3. So leading coefficient of 3, leading coefficient 3, leading coefficient -5, leading coefficient 3, constant term of -5, constant term -5. So A is the right option. The correct equation for a polynomial with zeros at x is equal to 5 and x is equal to -1, x is equal to -1/2 is x minus 5, x plus 1, x plus 1/2. So we should have x minus 5. So plus 5 is cancelled, plus 5 is cancelled, x minus 5 is the option, x plus 1, x plus 1/2. Determine the end behavior of the polynomial p of x minus 2x to the power 6 degree is equal to 6.